So what we're now going to start looking at is something called equations of lines. Okay. So let's write this down as a title. Have you looked at this before?
Like, I got this one in school, but like in my language, not as English.
Okay, so what is the general form of the equation of a straight line? Okay, that's fine. I'll go through it and then see if you can remember it, okay? Because I appreciate if you've done this before in school, it should be fairly familiar, so it'll just be a bit of a revision for you, but obviously just translating it into English rather than your language. Alright, fine, fantastic. So, the idea is, okay, this is kind of what we've seen so far. So in the last lesson, we kind of looked at gradients and midpoints and distances, literally we're just looking at. And the idea is, if I give you 2 points, so let's say a point here, so let's actually put some context here. So this is 1, 2, 3 and 4, and the same on this axis, 1, 2, 3 and 4, okay? Let's actually plot a couple of points on here. So let's go, for example, point A is going to be the point 2, 1, okay? And let's also plot point B, which is going to be 4, 3. So let's go here. So B is going to be 4 and 3. And the idea is, what I'm going to do is put a straight line through these 2 points. Okay, so I'm going to put the line in. I'm going to put the line in red again. Okay, so let's see. Let's try and draw this on the screen, on the board. Okay, so something that looks like that. It's not the easiest thing to draw on the board, but that's a straight line. Okay. Now, are you happy that the only thing that separates this straight line from any other straight line? There's 2 characteristics we need to look at. So actually, what I'm going to do is draw another straight line straight underneath it. So bear with me. So I'm going to draw the same set of coordinate axes, so the Cartesian planes. This is 1, 2, 3, and 4. And the same thing on this axis, so 1, 2, 3, and 4. And I'm just going to plot 2 other points on here. So let's suppose something like, okay, let's suppose I plot point, let's call this point C, which will be 1, 2. Okay, so that point C is 1, 2. And let's point another point over here, which we're going to call D, and that's going to be at 3, 3. Okay, and let's again draw my straight line through these points, so something like that. Okay. Now, what I want you to do is to look at these 2 lines which I've drawn here and here. So actually, let me call them a name. So let's call this line, so L for line, and let's call it line 1. Okay, and let's call this line L2, line 2. Okay. What's the difference between this line and this line?
That one just starts from the 0.
Good, well, not quite 0.
I mean, from the Y.
Okay.
And from my axis down, it starts from 2.
Okay.
1.5.
Yeah, exactly. So about 1 and something, absolutely. So you're right. So if you look at the intercepts on particularly this line here, okay, it crosses the y-axis way down here. It's something negative, right? Whereas this y-intercept is like 1 point something, isn't it? So they've got different y-intercepts. Now, what do you think the different y-intercepts will tell you? Why do you think it's important to have different y-intercepts? What does that literally tell you? So would you be happy that y-intercepts dictate how high or low that line is? Okay, so obviously this y-intercept is quite high, so the line is much higher on the grid, whereas this y-intercept is way down here, it's something negative. In fact, let me just continue this axis down. So it crosses way down here, it's something negative, which means that this line is much lower down than this line. Okay, so the first characteristic we need to observe is the y-intercept. Okay, so the y-intercept will tell you the height of my line. Okay, so the y-intercept tells you how high or low your line is. Okay, so that's one characteristic which sets the lines apart. That's one characteristic that we can say, well, okay, this line is different from this line because this line is lower than this line because it has different y-intercepts. Okay. What else? Are there any other characteristics that we can observe here which make this line different from this line? Think about what we were doing over there. Think about what we were doing last lesson. there any of those characteristics, gradient, midpoint, or distance, which can help us to define the differences between line 1 and line 2?
Yeah.
What?
The midpoint
Yeah?
and the grossman.
Good, absolutely, yeah. So the midpoint, well, okay, I've just selected 2 random points that I know lie on each line, okay? So it just depends which 2 points I use, and obviously the midpoints will be different, absolutely. But play on the idea of gradient, because you picked that one up, didn't you? What does the gradient tell us? What's another word for the gradient? Do you remember?
M.
Good, absolutely. So it's either M, it's the letter which we give to it. Do you remember what else we call it? It begins with S? Sometimes called the slope or the steepness. Okay?
But we can calculate the distance.
We can absolutely calculate the distance, but we need to have 2 points that lie on this line, okay? I just kind of define this, this line as the line which goes through these 2 points, or the line which goes these 2 points, okay? But it really depends which 2 points I'm looking at. Does that kind of make sense, okay? So obviously if I looked at 2 different points, for example this point and a point way out over here, the distance between those 2 points will be different, but of course are you happy that the line itself is like infinite? It can go on forever and ever and ever. That makes sense? Okay, so I think gradient is a better measure because are you happy, no matter which 2 points I look at, the gradient is always going to be the same?
Mm-hmm.
Okay? Just remind me, what does gradient actually mean?
The distance.
It's not quite the distance, no.
The measurement of the line.
It is a measurement of the line, but what quality is it measuring? It begins with S.
Slope.
It is slope. What's another word for slope? How steep the line is. Does that make sense? So the gradient kind of measures the steepness of my line. Okay, so the steeper the line, so obviously this line here is kind of facing in this direction, whereas this line here is slightly shallower because it's facing a slightly slower direction. Okay? So in other words, the 2 characteristics which set every line apart, which makes a line unique, is first of all, the Y-intercept, that will tell you the height of the line, how high or low the line is, and then also the gradient, which is the steepness. Okay, so how steep that line is. Okay, so we've just established then, the thing which makes every line unique are these 2 features here. So every line, if it's going to be different from 2 lines, so if I draw 2 different lines down, the way that we can define how they're different is the height, and we can do that by looking at the Y-intercept, and the steepness of that line. So we can do that by defining the gradient. So now what I want you to do is actually think, how can we calculate the gradient and the steepness? Well, okay, we can calculate the gradient because I've given you 2 points that I know lie on the line, okay? So can I actually ask you now to have a go at calculating the gradient for line 1 and the gradient for line 2? Okay, so did you get for line 1 the gradient is equal to 1?
Yeah.
Okay, and for line 2, did you get the gradient of line 2 equals a half? So what that means then, just to remind you, the idea of gradient, every time you move across by 1, this number tells you how many you move up by or down by. Okay? So in this case, with line 1, the gradient is 1, which means if I move across by 1, I also move 1 up. Okay? With this gradient, with this line, the gradient is a half. So therefore, if I move across by 1, I only move a half up. That makes sense? Okay. So which line is steeper, line 1 or line 2?
1.
Yeah, line 1, because it's got the bigger gradient. Yeah. So the gradient will tell you the kind of the direction of the line. So I guess you could write steepness, which is absolutely fine. Another word for it you could also say is direction. Okay, so it kind of tell you which direction is that line facing in. So if my arm is the line, it will kind of dictate which direction that line is facing in. Okay. But we also said, so the steepness is not enough. Okay, steepness or the direction of the line is not enough to make sure that lines are different. we can also have lines with different heights. So in other words, we also need to find the y-intercept. Now this reminds me, how do we find the y-intercept?
The x is 0.
Good, absolutely. So if we've got the equation of a line, we would absolutely set x to be equal to 0. Because of course the y-axis is literally the line x equals 0. It's the line where every single x coordinate is equal to 0. Good. But in this case, I don't actually have the equation of a line. Okay, I don't actually have the equation. So how can I do it from here? How can I find what that y-intercept is?
Is it the formula of distance?
It's not distance and it's not midpoint, but I think we can use the gradient. Because if you think about it, what gradient means is that every single time we move to the right by 1, it's how many we move up or down by. Okay? Well look, I know for example for line 1 that A lies on the line and it is at the point 2, 1. I also know the gradient of that line is equal to 1. Okay? Which means if I move to the right by 1, I should move 1 up. So surely then I should just keep going backwards until I hit that y-axis. Does that make sense? Okay? So in other words, if I go backwards, well look, if I go backwards, it means that by going to the left by 1, I should go, yeah, 1 down, perfect. So left by 1, 1 down, I end up at 1, 0. Left by 1, 1 down, what's the y-intercept? Yeah, good. So that y-intercept then is going to be -1. Now, do you remember the letter which we give to the y-intercept? So m we call the gradient. Okay. For the y-intercept, I'll do it in a different colour. The y-intercept we give the letter c. Okay. Some other cultures give it as a letter b instead, but in this course we call it c. Okay. This is the y-intercept, and in this case the y-intercept is -1. Okay. So could you do the same thing then, but find the y-intercept for this line? So this will be c1. What's the y-intercept of line 2?
Is it 2?
Sorry?
Is it 2?
It's not 2. So think about this point. 1, 2. If I move to the right by 1, I should move a half up. That's what my gradient is telling me. Which means if I move to the left by 1, I move a half down instead. Think about it. If you're this point here, 1, 2, you've said to me the gradient of this line is equal to a half. Okay? Which means that if I move to the right by 1, I move a half up. Well, I need to move backwards. I need to move to the left.
Yeah.
Okay, so if I move to the left by 1, how many should I move up or down?
Half.
Half down. Good, fantastic. So I'm here at 1, 2. If I move to the left by 1, I'll be at 0.
0.5.
Not 0.5. I was here at 2. I was at a height of 2. And now I move a half down.
Like 2 minus half.
Exactly.
2 minus half. It's 1.5.
It is 1.5. Good. Is that what you said?
I said it before 1.5.
Ah, okay. So maybe that was... Okay, maybe you were answering a question which I wasn't aware I was asking. Okay, let's put it that way. So okay, so let's say this y-intercept then should be at 1.5. So yeah, sorry, that was my misunderstanding. Okay?